Good afternoon, everybody. Friday afternoon. Nice to see everybody here. So I'm Jill Lerner. I'm the moderator, and I'm really thrilled to be asked by the Building Congress to moderate a project that I consider really innovative, having watched it go up during construction over the last 6 or 7 years. It's been extraordinary to watch. I don't know how many of you got up close and personal, but it was like amazing. And so this is a really, I think, important topic, both in terms of lessons learned and in terms of just having these experts be able to talk about the magnitude of the accomplishment. So I know that there was some discussion earlier about why has the press been so negative. And truthfully, I think it's really that they didn't really understand it. It was a knee-jerk reaction. But they didn't really is it really going to become a part of Manhattan? And if you look back historically, the press panned Rockefeller Center when it was built also. And they said, it doesn't feel like a part of Manhattan. No one's going to go there. The buildings are too big. They're too close together. And who today can imagine New York City without Rockefeller Center? So I think that it's a matter of not understanding what really took place there and how incredible the vision was and how a piece of Manhattan that had sat empty for over 100 years, dividing two parts of New York City, north and south, was knitted together in a very major way. And not just knitted together functionally, but in a way that it's going to become, and has become already, an important place in the city. So with that, what are the innovative aspects that got it done? And one of the things that I find amazing is that it was done in 6 years. And as Dan Doktorov said at one of the openings, he said, I know people whose bathroom took more than 6 years. So I thought that was a pretty good statement. So with that, why don't we start with each person just taking a minute and talking about, from their perspective, say what discipline you are and what firm, and then what aspect from your perspective made the project innovative as you saw it?
So I guess I'll start. I'm Michael Paquette. I'm with Langen Engineering. I'm a geotechnical engineer on the project, and I was involved pretty much from the inception, way back when it was the Jet Stadium before Hudson Yards, so I know an awful lot about the subsurface conditions out there. I think to me, one of the exciting things to see and really innovating things that we got to be involved with on the foundation side for a project that's a platform over a rail yard where the foundations are really critical to everything that's going on. And being involved with a private developer really gave us an opportunity to try and push the envelope on foundation design and make sure that we were coming up with a design that could kind of get them off the tracks as fast as possible. So one of the innovating things we did was embark in like a advanced load testing program. Went out, tested a whole bunch of deep foundations out there, and basically justified back to the DOB that we could actually get a lot more capacity out of the bedrock out there than what the building code allows. I did some math at one point in time, and I think there's something like 800 caissons on the job. They all average like 20, 25 foot long rock sockets, and they were like an hour a foot to drill. So like when you do the math, it comes out to be 2 years of a rig just hammering on the rock. So our ability to kind of go in and prove that we could really get a heck of a lot more rock out than what's traditionally, heck of a lot more capacity out of the rock than what's traditionally been used in New York really resulted in a lot of time and money savings to the job. So that was pretty interesting to be a part of.
You said they saved 6 months just on that alone.
Yeah, we estimated it something like that. It was like a 30% decrease in the amount of rock drilling that had to be done.
So if one of the goals of today's afternoon is to think about how we can build smarter and faster, that's a pretty good example of DOB working together with your office.
Right.
Bob Scymanski, KPF. I joined KPF in 2011, basically with an expressed interest in Hudson Yards. I had come from a large firm and always done large commercial projects, and I really didn't know what I was getting into. And in retrospect, the magnitude of the increase from my 30 some odd years prior to Hudson Yards to post Hudson Yards is just phenomenal. One of the things that Jill does a lot of public sector work. I gave a tour to Paul Katz's brother-in-law from Israel, who is an architect or a planner or some in that profession in Israel, and he could not believe that Related and KPF and the other people on the team would actually make decisions and keep building on those decisions and just keep rolling. He said, you don't have to go back to the government? I said, well, there's zoning and there's the building code, and we have to get permits, but we don't check with them monthly or quarterly or any. He just couldn't fathom that we didn't have those kind of checks and balances with the government. And then the other thing, I think it's not really innovative, but the use of BIM, which I was one of the ones that was sort of hesitant to take BIM on in 2011 in terms of our staff, outsource talent, and try to run a big job and try to gear up on BIM at the same time. Again, in retrospect, we could have never, ever done Hudson Yards in the time period that we did without BIM. It's just, we just would have never made it.
Did you feel that it integrated the architecture, the design, the engineering, and the construction more quickly?
All the visualization, we could go to a BIM session and see things three-dimensionally, talk about it on the fly, let's move this, let's move that. It was the coordination, it was just priceless, time-wise.
But
unfortunately, it wasn't
everybody
priceless
has to be
for our
on the
fee, but
everybody has to be on the system.
yes. Depending on who you're talking about, though, in one case, the contractor maybe took the lead on their portion of the model.
Right.
And then that made more sense because then their co-trades, so to speak, were feeding into them.
Right.
But for the most part, I mean, especially with Thornton Tomasetti, we relied on their model. In the beginning, we built structure ourselves just to have something in our model, but then we inherited their model at a certain point.
So
Mike.
and I'm Mike Squarzini with Thornton Tomasetti, and it's an interesting question about the innovation and building fast. And for a number of us on this stage, we've been involved in the whole time of Hudson Yards, and a lot of times it did not feel fast. We've come through the scars. And it's also an interesting site in that we've been working on that site for 20 years. So we knew a lot about that site and how to build buildings and how the approach to build buildings. And I think one of the innovative things that strikes me on this, and we've always prided ourselves as a firm on integration of design and construction. How do you build things? How do I take this from a model or a piece of paper that a contractor can then go build? And really this site was that on steroids because we weren't building from the ground. We had to build a platform. The logistics of that, there was really no way to build a project without that integration of designers, contractors, owners, all collaborating in that room together.
So when you say platform, are you talking a digital tech platform, or are you talking the actual platform?
I'm talking the actual
over the
physical platform in terms of, and tying into to Langen's points is where we could touch down was really driving a lot of the logistics of how this site was developed, frankly. And
for the benefit of the audience, can you just talk a minute about that challenge, about how many tracks were underneath and how many places or the limit on the number of places you could touch down from a structural standpoint?
So, I've never started a project where the first drawing we produced was a terra firma drawing just to identify the ground that we could actually land structure on. So it became the Bible of the project. It was, the track layouts with brown swatches that obviously did not really match an office grid layout. And that became the strategy of, okay, we can touch down here. So what does that mean to building massing, to building cores? And it influenced a lot of the design decisions that went in based on where you could actually touch down structure.
And then in construction, as I understand it, the sequencing of the order in which you could actually touch down had to be very closely coordinated with Amtrak.
Correct, because you could only take out 4 tracks at any given time. So the sequencing of the checkerboard of how we wanted to build that platform tied into the logistics of how quickly they wanted to get to retail, how quickly we want to get to Tower A. And a lot of the actual design that ended up in models and on drawings was really dictated by those logistics.
As I understand it, one other interesting thing about the structure is part of the buildings, part of the structure is supported and part of it is hung.
Correct.
And from the outside, if you go there, you can't tell which is which, right?
Right. And so from, if you can picture over the train tracks, you have an elevation of track, you've got a minimum clearance. We had structure that we could fit in there, and then the ground floor of the retail. Well, that could only support a certain number of floors, 5 floors. So you either build a 5-floor retail and stop, or what we actually did is there's a truss within the mechanical floor above the retail that actually hangs the upper floors of that structure, bridging over to where we could actually touch down on tracks.
All right.
But then construction sequencing, in essence, that same truss was built on ground.
Right.
Looked like it was going to be there for 100 years in terms of its robustness. The whole building was built, then its sister was built up top.
And took it out.
And then the lower one removed.
Right. So there was this constant collaboration with, again, how do you build this in a way that's efficient and fast and what is obviously a highly technical and highly complicated site.
Thank you. Ryan.
Ryan Stecher, JB&B. Been involved with the project since 2008. So probably one of the, I mean, there's a slew of things that we can talk about here, and a few things I can probably add on to what the gentleman to my right said. But probably one of the most interesting things was the decisiveness of the owner, right? And that's probably one of the biggest, most helpful things in this scenario on how we got to the point we're at 11 years later already, right? With, I don't know, 15 million square feet or so in the Eiffel Tower of New York, right? One of my favorite stories was when we were working out the utilities, right? Because there were essentially no utilities in this area because there was nothing here. There's no steam past 8th Avenue. The electric basically stopped at 8th Avenue. The IT was terrible. There was a couple of conduits floating around. So we were in weekly coordination meetings for permitting and things like that. And one of the issues we were stuck on is on 33rd Street, there was some IT conduits that had to move. The IT conduits are governed by ECS, which is like a government agency. So Brian De La Hunter from Related, who was one of the guys running the meetings, I said, look, Brian, there's nothing we can do on 33rd Street. We've got to wait for ECS to move the conduits. He said, well, how long is it going to take? I said, well, they've got to meet with Verizon. They've got to meet with AT&T. They've got to meet with all these crews. He was like, okay, great. Can we buy ECS? I was like, I don't think so. It might be illegal, but you can try. Needless to say, Related didn't buy ECS. But that was the attitude. And that attitude got a lot of things accomplished very quickly. And there were forced water mains on 30th Street and 10th Avenue that Related really drove a lot of the construction on. Even though these were public contracts, they really coordinated very, very well with, as well as you can with the city agency doing work. So.
Yeah, the decision-making of the client, I think, is one of the, I would say, not well discussed aspects of being able to move projects quickly. And I think that's been certainly my experience, and I think your experience as well from our discussions. And I think working with a private developer who can really move quickly and is experienced and has the ability to decide where they get materials from that can be produced quickly in new ways, in modular ways, without having to ask themselves, has it been done 25 times before? Is it a tested technology? Is this that isn't afraid to look around the world and say, there's a better way to build this. Maybe we should look in South America. Maybe we should get the steel from 2 places, right? Can you talk a little bit about those kinds of things?
If we follow that thread a little bit, and also to Bob's point on the modeling, one of the strategies from the very early stages was Thornton Tomasetti was going to, and again, it goes to blurring the lines between construction and design. We developed what's called a Tekla model. So this project has a significant amount of steel on it, about 100,000 tons, and hopefully an image will show up on the screen there, where a traditional approach for the non-structural engineers in the audience, a traditional design would be design documents, and then you hand that off to a contractor, and then they'd build their own model from which they would fabricate. They would design the connections, and then shop drawings would come back to the design team to review. So it was a very linear process. And in the last 20 years, we've been focused on kind of taking that lost gap of time and pulling it forward into the design of the building itself. And what you're seeing on the screen there is an image of the Tekla model that we actually developed and handed to a steel fabricator at the end of the day to actually fabricate from. So to Bob's point, having the BIM models to actually coordinate our work together is important, but then not stopping your thinking there. How can I hand that to a fabricator where it has value? and they can actually begin fabrication from that and shorten that time frame on a project like this, probably 8 months to a year. And what you see in this image is to Jill's point, is color-coded by the different fabricators for the project. So we had 4 fabricators coming from 4 different countries, over 100,000 tons of steel, and what knitted that all together was this model that the design team was controlling and developing throughout that design process. So as you can imagine, one was from Canada, one was from Mexico, one was from the US, one was from Italy, some are working in metric, some are in US. You know, I've been around the game long enough to know that's a recipe for a story that does not end well.
Potential recipe, right?
Right. And so, you know, knitting this together through the modeling and how, you know, Related had the foresight of how they were going to procure this was really what drove this schedule.
Yeah, and literally detailed all over the world.
Right.
There were conference calls and somebody would be in Slovenia.
Right.
It was amazing. And I thought also it was interesting, one steel erector.
Correct.
All different fabricators, but one erector to kind of have that centralized control of the erector.
Can you talk a little bit about the modularity of the project? I don't know who's best to talk about that.
Actually, Bob, you want to take on the vessel?
Well,
You want to go
I
into a
think
little bit of it?
we have some
Talk about the
vessel
vessel.
images. The vessel started the idea, and basically the name of the game would be to have parallel paths of production so that you're doing something on the site and then you're doing something else off-site. It's like, you know, Curtain Wall has done that for many years. So Related had the idea of how could we do that on the vessel. So the vessel, Thornton Tomasetti had developed basically simple end plate connections. So you had the platform, half a stair up, half a stair down, twice. So that was affectionately called the dog bone. The structure, the full structure ends up being about 90 dog bones. And then Related said, well, you know, we're talking to Chimolai and we're going to talk to them about prefabrication. And then they kind of put their foot down on the gas, and it ended up being prefabrication, painted, plumbed for storm, wired for lighting, and clad except for where these 2 stairs connect. All in Italy. Labor relations were worked out, everything was worked out, and the whole thing basically worked. One of the things that Chimolai did to make sure it worked is they assembled the vessel in their yard while the vessel was still a top secret. So there was a screen wall, there was worried about drones, they were worried about some kid on a Vespa driving by and taking a picture. But basically they built it halfway up because they were just in a yard and they hadn't bolted it down, so it was not going to be stable at 150 feet. Everything that was wrong was fixed. Obviously, every component has a certain location to be. And then got halfway up, said, okay, we're satisfied. Took it all apart, and then took that middle ring and built it again on false work that kind of represented the lower dog bones, and then went up again. So they basically did 2 75-foot vessels in 2 strategies. And then they knew, you get to New York, you know, the crane is expensive, everything's expensive, but they knew the end plates would fit, the bolts would fit through. There was basically nothing didn't fit here. It had all been addressed in Italy.
I think the other thing on the modularization, and again, we credit Related for really pushing the design team, was on the observation deck of 30 Hudson, and there should be an image of that coming up in a minute, was, you know, 2 years before that was built, they were challenging the design team again, how am I going to build this 1,200 feet in the air with essentially no scaffolding below it? And so they challenged the design team, how do I modularize the erection and construction of that observation deck? And so it was Chimolai as well, where we took what was an 80-foot cantilever by X 200-foot dimension and broke it down into 13 modules of pre-assembled trusses, connection details all worked out. So we had 2 choices. We could either try to stick build this in the air and work your way out on that cantilever with nothing below you, or do what we did here, which was erect erect this structure fully clad with modules on it, and it required KPF's input, JB&B's input on detailing the joint between those facade panels. What was that going to look like? Is the original design intent going to be met? And you can see, anecdotally, as you walked around the city, all of a sudden everybody was looking at that building saying, well, where did that come from? Because we were able to erect that essentially in 13 crane picks. You can see in the image on the left, 13 double crane picks, because these were heavy pieces as you worked out on that cantilever. But again, it was a very, very quick way to build a very, very complicated structure that really is going to be that feature of that tower.
Now, it's not open yet, right?
It is not open yet. We've all been up there in various capacities, and it's pretty spectacular.
Yeah, so something to look forward to.
I think to go back to the boldness of related, also I think it's important to understand it wasn't a traditional developer and construction manager relationship. They are their own construction manager. So the people that were on site, that everyone, Tishman, Tudor Perini, et cetera, they actually were agents of Related, and Related had a core construction team of executives and others that were basically directing the work. And so in terms of, it's not a risk management strategy that one would recommend, but to save time, they took on the risk that normally those CMs would take on to some degree.
And what drove the need in your minds for Related to want to push this so quickly?
Well, I would think it usually comes down to money.
Time is money, right?
Yes.
Yeah, I could probably vouch for that too. So just going back to being on the tracks before the platform was up, I remember being out there on some days and just watching the caissons being drilled. Like I said, it was an hour per foot to drill. And you just look around and there, on a normal construction site, maybe you got the engineer, a couple dock builders, an operator, right? You got 4 or 5 people. This was 30 people at a time per, every hour just sitting there. Like, the faster we could get out and get off the tracks it was huge to the project. So.
One of sorry, Mike.
Go ahead.
One of the time constraints, one of the interesting, we haven't really talked too much about the jurisdictional issues, obviously, that went on with this. Bob sort of made reference to it a little earlier, but as the platform was being built, right, this went from an open air space with rain falling on it to at some point an enclosed space, right, that the fire department in theory had to fight fires in potentially. And it was a commitment to the railroads, we were going to fully sprinkler it and everything would be fine and it would be an indoor space. Unfortunately, there's like a time in between. Now, if you were working on, I don't know, say a public project, they would build a section of it, sprinkler it, get it signed off, move on to the next. And what was interesting is some of the constant coordination. I mean, there were weekly meetings with the FDNY and the Department of Buildings and commissioners of the Department of Buildings, et cetera. So we probably monthly there would be like a site safety meeting. And what ended up happening is the platform was sort of built in segments, as Mike was saying earlier, depending on which building we were working on, but they would leave a certain amount of leave outs so that if there was a fire or something below in the track space, right, you would have sort of a natural ventilation to the track. And then once they enclosed that, they would then commission that part of the fire alarm and the sprinkler system. And it was pretty interesting, but it was literally working hand in hand with the authorities having jurisdiction, the Department of Buildings, et cetera.
So you had a lot of support from the city.
Absolutely.
In order to really facilitate this and make it happen.
Right.
That's exactly right, Joe.
And I think to both your points is we've all done buildings adjacent to MTA structures or other, interested parties, but what's unique about this site is you're building on top of them. So the focus of that, which was why Related needed these construction management individuals and leadership that could actually speak the language of construction and then integrating with public agencies, with the design team, and that's really, I think, maybe it's not the unique thing, but the thing that emerged from this was really that collaboration on an ownership, a builder, public agency, a design team side was something that I hadn't really seen to this level. I don't think you could achieve this project without that.
Yeah. And they got together to finish the Gateway Tunnel. Our portion of the Gateway Tunnel is done.
Right.
Sitting there waiting for the politicians to connect to either end.
That's amazing, actually.
It really is. And that's, we were talking earlier, Joe, right? As a juxtaposition, I've done a lot of work on a trade center site, for instance. Right? It's, when you look at it on paper, it's not that different of a site, right? It's, 12, 15 million square feet on each one, roughly the same square footage.
Built over a lot of rail.
That's exactly it, Joe. Yep, built over an active railway, right? And you look at how quickly Related finish this as compared to what's gone on downtown. And I'm not taking jabs at the port by any stretch of the imagination, but one of the things that Related did well was make decisions. Now, they made a lot of them and changed them, but they made decisions and at least gave us a direction to go. When you work with, a public agency in a lot of cases, and I'm also working on Moynihan Station and things, sometimes a decision gets proposed, it gets vetted, it gets checked, you have to run it past a lot of people before you can really integrate that solution. With Related, when we were talking about Hurricane Sandy, when Hurricane Sandy hit, our office was taken down. We were in a temp office at 641 Lexington. It looked like, it was like a trading desk, like that movie Boiler Room. We're all sitting around fold-up tables, and within 2 weeks, we were backing every building up with generators. Then we weren't backing up every building with generators. Then we were flood-proofing the basement of 10 Hudson Yards. It was just everything happened within weeks, and it was, honestly, it's incredible. It's a lot of fun to work on projects like that,
Can you talk about some of the other changes that were made during construction for after Hurricane Sandy?
The big thing, kind of right off the bat, were platform jobs. So you're at 40, and even though the numbers varied, and your office helped us a lot on the numbers of what Sandy was and wasn't, but the vast majority of our equipment is high, but obviously fuel oil's down there, elevator pits are down there. So 10 Hudson Yards has a drive entrance on 30th that is maybe at 12 and a half. So we thought that was a vulnerability. And in the end of the study, we ended up assigning ourselves a design flood elevation of 13.4, where we had been at 7'6". So we came up a lot. There was a lot of structural implications that TT had to deal with. That's the only building with subterranean parking. But what was interesting is then we, I think a little too much kind of tunnel vision. The one thing from Related was the next day we want the elevators running. So we looked at each pit or bank, but there were 27 some odd elevators. So it would have been a lot of moves over a lot of area. And one of the Related executives said, "You guys, it's a concrete building, you got a concrete core. Why don't you just put a seawall at the end, put in 2 big doors and be done with it?"
Submarine doors.
Submarine doors. I don't care if the parking floods, we can take the fish out the next day, but keep the whole
elevators.
eastern side dry, and that's what we did. And thankfully it hasn't been tested, and I hope it doesn't get tested, but it's there to do the job.
So one of the things that there are a number of takeaways and lessons learned, I think, that are really valuable, having to do with decision making, having to do with coordination, having to do with being able to change the paradigm, if need be, really quickly, and have the design team and the city and the developer and the contractor all in the same hand in hand, really working together to make changes. I know there were a lot of changes as Related was leasing the building, and that impacted the design as well. And there were a lot of changes that made structural changes, core changes, even building configuration changes.
Right.
So just...
That's a great point, Jill, and I don't think we addressed this either, but if you want to talk about adding complication, not only were we doing all these at the same time and there were all these leasing considerations, right? We were doing this huge campus. And from an MVP perspective, the thought is, okay, you do some common systems and you distribute out to the buildings, very easy. Related didn't make that very easy because they decided then to condo out each of, like even Tower C, the major tenants, 10 Hudson Yards, own a portion of that building. So one of the tenets of kind of the I'll say the MEP strategies or the common strategies was don't do any common plants. We need everything to be standalone and we need to be able to condo it out. So we couldn't, like if you did a university, you did a hospital, right? You would do a common chiller plant, you would do things like that. All of that stuff was off the table, with the exception of the large cogen plant, which again went out of the job and then came back into the job again. But it was a real strategy. We had to decide. It affected our MEP strategies because we tried to reduce the amount of common elements so that these people could really have ownership to each of the sections of building. I apologize for cutting you off, but it's something that really added an additional complication to the process.
Well, it's really interesting because at the end of the day, if it's not leased, it's not going to be vibrant, right? You have to, and it's not going to pay for itself, and you need those tenants to make the thing work financially and also to make it a lively place and make it what it's intended to be. So one thing we haven't talked about is sustainability. What kind of innovative strategies You know, it's rare. I mean, I guess the analogy to the World Trade Center site is actually really interesting because I know for a lot of our projects in Asia and really in Asia, we're designing like whole districts from scratch. And it's rare in New York. You know, you might do a building, even a very big building like One Vanderbilt. It's still, and it might be a core building that will sponsor a district, and it is also connected to transit. But this was really the opportunity to build many buildings all at once and set up a framework or a platform to allow a whole neighborhood to be built. Now, first for the East Yards and then the West Yards, right? So what was unique about the fact that it was a district-wide plan, and also how does that help you in terms of sustainability, or are there other sustainable strategies that you used that you hadn't used before?
So,
And as they
Yeah,
say
go
on CNN, you have 30 seconds.
yeah, that's a lot to
Actually,
pack.
I think we're at the end of the time, aren't we?
Yeah, we are.
Oh, we are.
But
I'll
Quick.
just give a quick 2 second.
One answer.
Basically, there's a 13 megawatt cogen plant on site. Thank you very much, guys. But we looked at everything. I mean, we looked at everything for the East and West, and that was really what sort of worked out financially.
yeah, and just in the last seconds, I think what's interesting too is we did everything that most architects would do. We did the cogen, but we also, at Related's urging and direction, looked at systems that weren't going to be provided, but the infrastructure was going to be there, or the idea was going to be there. Interestingly, not many tenants, at least yet, have picked up on those systems and incorporated them into their TI work for whatever reason. We had food waste turns into a slurry, goes to the basement, and is compost in 2 weeks, or things like that no one seemed to be interested in.
But Related put the infrastructure in for it.
Well, did the kind of the thought process and said, here's the system, this is what it would take up in your kitchen, you drop a line to the basement, we'll give you a parking place, or you're going to buy a parking place, but no one, it was interesting that on the tenant side, sustainability wasn't as much of a driver as I thought it might be.
Interesting. Okay, so we have to end, and unfortunately no time for questions in these panels, but it was a pretty technical panel, but I hope you hung in there and found it interesting and useful, and thanks for hearing about some of the details on Hudson Yards.
Yeah.